Okay, in this video we're going to take a look at a little bit more of an algebraic approach as we start playing around with the equations of these quadratics or parabolas. So we're going to take a look at finding the equation of a parabola given some other information. In the first example, we're going to find the equation of a parabola given a graph. So let's grab some graph paper and let me sketch a graph for you. And so here's a graph, and I'll call it y equals f of x. It's a function. So now, what's that equation look like in terms of our x minus h squared plus k equation? What's this equation look like? And it's not too difficult. I can locate the vertex and see that it's at 2, 3. So that gives me some information that the h is 2 and the k is 3, and now I need to just go and figure out what this a value is, and I do that by going from the vertex and looking at how the basic graph has been skewed, and in this case it's now a downward facing parabola and it's been skewed by 1, and I don't need to write the 1 in there, and I have the equation of my parabola given the initial conditions, which was the graph of the parabola. And we could do similar things if we know just some information and maybe not the whole graph. Let's take a look at that kind of example. So in this example, we're going to find the equation, and again that means y equals ax minus h squared plus k. Find that equation given a vertex, and so that vertex we can use right away. That automatically tells us we're dealing with y equals x minus 2 and plus 5, and it has to have an x-intercept of 0, and the x-intercept of 0, this is an x value and this is a y value, so in our equation if x is 4, then y has to be 0, and the other parts have to be true. And that only leaves us with an a value left over. So if I do a little bit of algebra, 0 equals a, and then 4 take away 2 is 2 squared plus 5. That leaves me with a times 4, 4a plus 5. And now I just am solving for a, and that's the only thing that I didn't know in my equation up in this step is that a value. So I subtract 5 on both sides, and I divide by 4, and I get a little bit complicated fraction, but that's totally okay because now I can use that fraction to say, okay, my y value is equal to, here's my a value, and then x minus 2 squared plus 5. And if I were to graph that, it would have a vertex of 2, 5, and exactly have one of the x-intercepts be at 4, 0. And I didn't have to graph it, which was nice, and I'm just basically going from an algebraic approach, starting with information that I know, usually a vertex, sometimes a graph from which you can get the vertex, and then some more information. In this case, the x-intercept. In the graphical case, I had more information in terms of the a value by looking at what's the scale factor in that y direction to be able to calculate that a value straight off of the graph. Okay, that's what we'll get to play with next class. So this is short and sweet, and we'll see you in class to practice.